Originally, in the very initial days of internet, the DNS service was provided through this file called host.txt. At that time, there were these different sites and each site had many hosts. So there are many such sites. And there is a central authority. So what these site managers used to do is whenever they added a new host, they would contact the central authority and mention the host name and the IP address of this newly added host. And this central authority used to add this entry in this host.txt, and then it is going to send this file to all the hosts in all the different sites. So each of this hosts now have this file, and if you are establishing a connection, you just look at this particular host.txt file, which is local, figure out what the IP address is, and thereby establish the connection. Well, as internet grew, this approach definitely didn't work, so they needed to come up with another architecture. So what are your thoughts? How would you implement DNS? So one solution is, instead of the host maintaining this host.txt, what they can do is they can contact this central authority saying, give me the IP address corresponding to this particular host name, and this central authority looks at this host.txt file and gets back with the correct IP address. What can be the problem with this particular approach? You should be able to answer this by now. Well, quite a few. Whenever you use a centralized architecture, there is a danger of a single point of failure. If this central authority failed, the internet will go down, because DNS is a very crucial aspect of the internet. Without it, you cannot establish connections. Not just this, this particular central authority server has to cope with high traffic volume, because every host will want the host names and domains resolved. And also, where would you place this particular server, the DNS server that is? If it were in America, then all the people that are there will have low DNS response time, whereas people from India will have high DNS response time, which is again not desirable. Also, the number of entries that you need to maintain at this central node is going to be rather huge. That will lead to database maintenance problems. Overall, this centralized architecture is not a scalable solution. So how would you solve it then? Hierarchy to the rescue again. So the way the DNS is implemented is via a hierarchical and distributed implementation. So you have these DNS servers at different levels. At the very top level are these root DNS servers. There are 13 such root DNS servers. Each server is not an individual server, rather it is a cluster, and these root servers are managed by ICANN. You have heard this name earlier in the context of IP address allocation. In the next level are what are called this top level domain servers. There are quite a few of them: com TLD servers, org TLD servers, edu TLD servers, net TLD servers, so on. So this 6 are all based in the US, and these are country specific TLD servers. So IN stands for India, FR stands for France, UK stands for United Kingdom. So these TLD servers are again run by different companies. For example, VeriSign company manages this TLD server for the com domain. Below this are what are called authoritative DNS server. So for example, each organization maintains its own DNS server. So there is Amazon's DNS server, Facebook DNS servers. So these fall under the com domain because these are companies. And then there is Wikipedia DNS server, which falls under the org because it's an organization. And then there are educational institutes like MIT, Berkeley, which fall under EDU. Let's look at this India zone. Within this Indian zone, there are multiple other zones. So there is CO to represent companies, AC to represent academic institutions, Gov to represent government organizations. So the IITB falls under this AC zone. And similarly, this MCGM stands for Municipal Corporation of Greater Mumbai. It falls under government. And the CSE department within IITB will fall under IITB. So there will be some authoritative DNS server that is being run as part of the CSE department. Similarly, IITB itself will have some authoritative DNS server that is going to handle the different departments. And this academic DNS server is going to handle the various academic institutions within India. Also, there are some that are directly connected to the India. So olx.in, for example. So as you can see, there are multiple levels of hierarchy. At any given hierarchy, there are different DNS servers. Another very important server is the local DNS server. So this provides the DNS service to hosts within an organization. So all the hosts within an organization will contact the local DNS server to resolve the host names. And these hosts obtain this local DNS server's IP address during boot time, typically via DHCP. So if you're in Linux, you can figure out who your local DNS server is by looking at this particular file. So how do these DNS servers interact to help resolve your queries? We will see shortly. So here is a map that indicates where all the root servers are located. Majority are located in the US itself. There are 2 in Europe and 1 in Asia. So this example tells how DNS works. Have you ever been to a government office to submit a file or get some information? What happens there? You go to one person and you ask him for some information. He says, I don't deal with this. Why don't you go ask someone else? So you go to the someone else and he says, no, I also don't deal with this. Why don't you go ask some other person? DNS does something similar, except that your query will very likely get answered, whereas it may not be in a government organization. Anyways, here is how it works. So here is the host which wants to find out what is the IP address of this particular host name. So what it does first, it is going to contact its local DNS server. So this is indicated by this message 1, wherein it will ask what is the IP address of www.facebook.com. Now this local DNS server is configured with the IP addresses of the root DNS server. How does it get the IP address of the root DNS servers? This information is widely available. If you are setting up a DNS server, you will have to somehow figure it out. Since it knows the IP address of the root DNS server, so this is the Japan's root DNS server. So it is now going to send this query to this root DNS server that is indicated by 2, and it is asking what is the IP address corresponding to this particular host name. Now what this root DNS server does is it is going to look at the string, and this string has a very specific order which captures the hierarchy mentioned earlier. So the root DNS looks at the last portion, which is the COM. So it is going to reply back saying, I don't know what the IP address of this is. Why don't you try the .com top level domain server? And here is the IP address of this. So the root DNS knows the IP address of .com, not only .com, it will know .net, .org, .in, so on and so forth. And it is going to pass the IP address to the local DNS server. Then what the local DNS server does, it is going to contact this COM TLD server and again ask what is the IP address of this www.facebook.com, and this TLD server is then going to look at this portion and it says, oh, this is Facebook, so I need to pass information about the Facebook's authoritative DNS server, and that's what it does. So this a.ns.facebook.com is the authoritative DNS server of the Facebook domain. So it will say, I don't know what the IP address is. Why don't you contact the Facebook's authoritative DNS server, and here is the IP address for this. And now the local DNS contacts the Facebook authoritative DNS server. Since this is the authoritative DNS servers, this will definitely have an IP address corresponding to this. So this gets back with the IP address. And once you receive this message, you then pass it to the host. The local DNS server passes it to the host. And you just thought you type in this URL and your web browser establishes a TCP connection to the Facebook's web server. As you can see, there's a lot of action behind the scenes. As many as 8 messages can potentially get exchanged. In reality though, the implementations are a bit more efficient. So what this local DNS server often does is it is going to cache the entries. For example, it may maintain a cache which specifies the mapping between the facebook.com web server's host name and the IP address that corresponds to this. So if some other user within this organization were to contact this local DNS server, it won't do all this. It will reply based on the cache. But these entries, like anything else we have seen before, have a time to live field, after which these entries are removed. Then again you will have to get the IP address by sending out many messages. Another thing these local DNS servers do is also cache this .com TLD IP address, .org TLD IP address, so on and so forth. That way they don't have to contact the root server always. So caching can happen at multiple levels. So we will break here. Up ahead we will see what are the entries that are maintained as part of the DNS server's database and how the entries got into the server in the first place.